Okay, back now. Some technical difficulties earlier in the day, so I could not do any videos earlier today. I'm now going to move on to what would be, I think we're Unit 7 I'm looking at right now. I'm hopeful that the schools might open up later, and it would be better if we did Units 4, 5, and 6 in person. So I'm going to move to Units 7, 8, and 9, which are geometry and measurement based. So we're going to start with our first unit, which would be two-dimensional measurement. I will post all of the links you'll need to this in the LMS. So I'm just going to get started and summarize what we see on this particular slide. So we're looking at the Pythagorean theorem. I believe you'd be well versed in that. So 3, the exponent is 2, that's read as squared. Geometrically, because it would be the area of the square. 3 squared is 9. Now, I'm going to give you a couple of seconds to think about the answer to this question. Andrea thinks that 5 squared will give the same results as 5 times 2. Do you agree? Explain. So I'm going to pause and let you think about that. Okay, we're back. 5 times 2 is 10, and 10 is not equal to 5 times 5. So Andrea would not be correct, because 5 squared is 5 times 2. Now, why is 4, when we have an exponent 3 there, why is it called cubing? What does it mean? So I'm going to give you time to think about that. So it's called cubing because geometrically this would make a three-dimensional object. It makes a cube. 4 by 4 by 4. That's why it's called cubing. Next slide, just reviewing the Pythagorean theorem. So the Pythagorean theorem is named after the Greek mathematician Pythagoras, although we have lots of evidence in math that the Babylonians actually understood this formula first. So in order to use the Pythagorean theorem, we do need a right angle triangle, which we do have here. We have probably gone over to find the hypotenuse, that what you should do is draw an arrow from the right angle, and that's going to intersect with the side that's the hypotenuse. So the hypotenuse is the longest side. It is opposite the right angle. The other two sides, A and B, have special names. They are called legs. And the Pythagorean theorem says that the area of a square off of the hypotenuse would be equal to the sum of the areas of the squares off of the two legs. And I'm just going to highlight that because that's the formula we are going to have to be using at some point during this lesson. All right, moving on to the next slide. This is an example of what the Pythagorean theorem is saying. Let me pick up the pen. Let's put H here. There's A and there's B. Notice this is A squared. Notice this is B squared. This picture had C, but I'm going to change it to H for hypotenuse. H by H, and that is H squared. Back and notice the area of this is 5 by 5, so there are 25 little squares here. The area of this is 4 by 4. There are 16 little squares here. The area of this is 3 by 3, and so there are 9 little squares there. And what that is showing us, that 5 squared is definitely equal to 4 squared plus 3 squared. 16 plus 9 is 25, and 5 squared is 25. So that's sort of an illustration. Moving on to the next slide. Maybe I'm going to upload this. This is a bit of a puzzle. These pieces, they all come off. Maybe I'll see if I can find a way to upload that for you. And then you can try and move it yourself to see if you can. This is a visual proof of the Pythagorean theorem. If you can cover the yellow area with the green and red, then that's a visual proof of the Pythagorean theorem. I'll try and upload that, and you can try that on your own. We have some visual proofs here of the Pythagorean theorem. I think we did some of these already. I'm just going to go over this one first. Maybe I'm just going to do one visual proof, and then I'll upload the other one, and you can look at it and see if you can figure it out. So right now we have 1, 2, 3, 4, 5. So this is really a pentagon here. This pentagon is comprised of a magenta purpley area. That's a triangle, a green triangle, and a sort of a gray triangle. And then we have this big white square here. And the area of the square right now would be H squared. If I rearrange this, note I have not created any new area. I'm just going to show you that again. No new area was created because we are not stepping outside of this pentagon we see here. No new area is created, but now we've reconfigured the white area. So I'm going to come over here, and I'm just going to note that at this point, h squared is equal to the white area. Then we're going to go here, and now we can see we've created a square here and a square there. So now we've reconfigured, and we're showing that the white area can also be a squared plus b squared. So that's a visual proof showing that those two white areas would have to be equal to each other because we didn't create new area. So that's a visual showing that h squared now and a squared plus b squared have to be the same thing. And then I'll upload this one and see if you can follow that one. And then there's another visual sitting right there. This one's a similar idea where we're looking at 1, 2, 3, 4 gray triangles, and then we have the black area. And then the black area is reconfigured as a squared and b squared. All right, what I'm going to get you to do now is I'm going to pause this momentarily, and I want to see what you remember about the Pythagorean theorem. So you'd have your note in front of you now and a piece of paper. I actually want you to work through this, apply the Pythagorean theorem, and find the length of S. And I'm going to do that as well. Okay, we're back, and now you can compare your solution to my solution. So what I did for you was I drew the arrow coming off the right angle, and remember we said if you come off this right angle it will point to the side that's the hypotenuse. So the hypotenuse is x, and it doesn't matter which of these you label a or b because the addition down here is commutative. B squared plus a squared would be the same result. So I started, we talked about proper form. This is like writing a math essay. So kind of there's my introduction. H squared equals a squared plus b squared. I'm now going to plug in an x for the hypotenuse. So I'm going to plug in a 5 for a. I'll plug in a 12 for b. 5 squared is 25. 12 squared is 144. And 25 plus 144, or 144 plus 25, both give us 169. To undo squaring, we will square root. So now x is the square root of 116, so x is 13. And I'm going to consider that to be my conclusion. Now I want you to apply the Pythagorean theorem to this. Now notice what I did here. It's different orientation. Students are more successful if I allow the legs to be vertical or horizontal. But in here I do not have the legs being vertical or horizontal. So I'm going to get you to work on that one. Alright, now I'm going to sort of discuss the solution here. Again, I started with the right angle. I drew an arrow away from that because it will point to the hypotenuse. And you do indeed have to have the hypotenuse correct. It wouldn't matter whether I labeled this B or A or this B or A. In this case, I've chosen AB. Notice I've started with my introduction. H squared equals A squared plus B squared. I'm going to plug in the 20 for H, the X for A, the 15 for B. 20 squared is 400, 15 squared is 225. Notice how this is different from this one though. The unknown is sitting over here. So I'm going to have to use my solving equations techniques. The additive inverse of positive 225 is negative 225. So I will rewrite this as 400 minus 225 is x squared. 175 is x squared. The square root of 175 is x. So if I take out a calculator, it gives me x is 13.2287, and I'm going to round that to 13.2. All right, let's look at the next slide. On the next slide, I think what I'm going to do is pause. Notice the unknown here is the hypotenuse, and the unknown here is one of the legs. Traditionally, it's easier to solve when you're solving for the hypotenuse. What I'm going to let you do, this is practice. So I think you should probably pause this video for about 5 to 10 minutes now while you attempt to do both of these. And when I pause, I'm going to be answering both of them as well. So you're going to pause now. Okay, we're back now, and I'm just going to walk you through the solution to the left one, then I'll walk you through the solution to the right one. It's going to be up to you now to have feedback whether or not you use proper form, because we do not have whiteboards here. So remember, I'm going to start with my introduction. H squared equals a squared plus b squared. I drew my arrow off the right angle, so I now note that the hypotenuse is x. I plugged in x squared. I've plugged in a 5 here for A, and I've plugged in an 8 for B. 5 squared is 25, 8 squared is 64. Notice my lovely form here. I'm not breaking this up and off to the side writing 5 squared is equal to 25, 8 squared is 64. I know we reviewed that a lot. Proper form. Make sure you went from here to here. 25 plus 64 is 89, so now we know x squared is 89. X is the square root of 89. And I forgot to discuss in the previous slide, this is now approximate answer now. Square root of 89 is exact. So I should put a little dot above it to say x is approximately 9.4339, which I'm then going to round to x is approximately 9.4. All right, let's look at the next one over here. Maybe I'm just going to close that. Again, I'm going to start by drawing the arrow off the right angle. It's pointing to this side, so the hypotenuse is 15. It doesn't matter which of these I label A or B. I've chosen to label this as A and 12 as B. So 15 squared equals x squared plus 12 squared. Also forgot to mention, started with the introduction. 15 squared is 169 is equal to x squared. 12 squared is 144. And as before, when you are solving for one of the legs, you're going to have to use equation solving techniques, because the Pythagorean theorem is set up to help you isolate quickly for the hypotenuse, not for one of the legs. The additive inverse of positive 144 is negative 144. So 69 minus 144 is 25. So now we know 25 is x squared. The square root of 25 is x. And now there's my conclusion. X is 5. Just try and use proper form when you're setting up your solutions. All right, so I've got some help here from my son, Mr. Hanta Jr., as I made a big boo-boo there. 15 squared is not 169. 15 squared is 225. So 225 equals x squared plus 144. 225 minus 144 is x squared. 81 is x squared. The square root of 81 is x, so x is 9. And Mr. Hanta Jr. helped me put this little clip back in. All right, next page. This is sort of a bit of a word problem. So you've got this guy wire. There's your guy wire. It's attached to the top of a 30-meter tower. We're anchoring to a point 10 meters from the base of the tower. Find the length of the guy wire. This would be an application of the Pythagorean theorem. I'm going to let you work that out. Notice there is indeed, if you need a bit of a hint, there is indeed a right triangle here. We're going to presume it's a right triangle because we're going to presume that the radio tower was put in vertical. And I'm going to pause now to let you do the work. You should pause as well. All right, so hopefully you took time to attempt that problem on your own. Again, I'm going to point out to you that there is indeed a right triangle sitting here, here, and there. They've marked it as a right angle. We said we're going to presume that that was vertical. I now draw my arrow so I can identify which one's the hypotenuse. It turns out the guy wire is the hypotenuse. I introduced the letter x to represent the length of that guy wire. Starting with my introduction, letting people know the formula I'm using, I'm going to be using h squared equals a squared plus b squared. The hypotenuse is x. And then I'm just going to plug in 10 and 30 for the legs. It doesn't matter in which order I do that. 10 squared plus 30 squared. 10 squared is 100. 30 squared is 900. 100 plus 900 is 1,000. So now we know that x squared is 1,000, which means that x is the square root of 1,000. And that's going to give us that x is approximately 31.6. So the guy wire is 31.6 meters long. Now let's see what's coming up. Now, there is another word problem. So I guess another application of the Pythagorean theorem. We're going to have to make a presumption here, though. Look how this diagram is laid out, right? The way it's laid out, we would not be able to use the Pythagorean theorem. So we are going to make this presumption. We are going to presume that that's a right angle. That will allow us to use the Pythagorean theorem. If we don't presume that, we can't use the Pythagorean theorem. Again, I'm going to ask you to pause. Spend about 5 minutes or so setting this up. Remember all of the proper form we had from the previous examples, starting with your intro, then plugging in the values where they belong, etc. So let's see if you can do this one absolutely spot on with no mistakes in proper form. Okay, I'm going to pause now. I'm going to ask you to pause. Okay, we're back. And again, in our initial discussion, we had noted that we had this triangle here. There wasn't a right angle marked on it. So if I want to use the Pythagorean theorem, I'm going to presume, of course, the wall is vertical. But that's what we try to do in construction anyway, is make for vertical walls. We don't want to, we're not trying for the leaning power of Pisa. So that should indeed be a right angle there, or very close to it, close enough that it wouldn't matter. All right. So I started with my introduction, h squared equals a squared plus b squared. Notice how I drew an arrow off that right angle, 6, giving the hypotenuse of 6. Did you plug 6 here as opposed to over here? Because a common mistake in this question is for students to put 2 squared plus 6 squared. That's incorrect because 6 is the hypotenuse. So 6 belongs here. It doesn't matter in which order I write the 2 or the x. And notice over here I put my variable. The unknown for how high up the wall this ladder will reach. So the correct way to do it is to say 6 squared equals 2 squared plus x squared. 6 squared, 6 times 6 is 36. 2 squared, 2 times 2 is 4, plus x squared. Again, just one added layer of complexity when you're isolating for a leg is I'm now going to have to undo this. And the additive inverse of positive 4 is negative 4, using equation solving techniques from the previous unit we were looking at. 36 minus 4 is 32. How do you undo squaring? With square root. So the square root of 32 is x. I took out a calculator. That gave me 5.656 was x. I underlined this a little bit here to show you, because if we are going to round, I'm looking at what comes after the 6. 56 is definitely greater than 50, so we should be rounding to 5.7. And then I wrote a nice conclusion over here. Therefore, the ladder reaches 5.7 meters up the wall. All right, let's look at the next page. All right, I'm going to get you to think about this one. We know the distance from Ennis to Carlo is 24, and the distance from Carlo to Shannon right here is 28. Can we use the Pythagorean theorem to find the distance from Ennis to Carrick on Shannon? I'm going to pause and give you some time to think about that. Give some thought to when are you allowed to use the Pythagorean theorem. I'm going to ask you to pause, and I'm going to pause. All right, so hopefully you gave that some thought. So in order to use the Pythagorean theorem, I suppose we need a couple of things. One, we do need a triangle, but not just any triangle. It's specifically a right triangle. Oops, that's not very straight, but let me put that in. That was meant to be a right triangle. Let's take a look at this. This most certainly is not a right triangle. And given that it's not a right triangle, we're not going to be allowed to use the Pythagorean theorem. So let's make note of that. All right, not a right triangle. So cannot use Pythagorean theorem. So in grade 10, you will explore ways using trigonometry to make calculations in triangles that are not right. All right, moving on to the next slide. I'm going to say we saw this before because we did do this problem for those of you who took GLE. So how many linear feet of wood would be needed to build this truss? And trusses are used to support the plywood that you're going to construct the roof on a house with. And they have shapes like this, and you stack a bunch of them. So you kind of pull this forward, if you can imagine that, through space. And that's how you'd create your roof line. So what I'm asking you to do, so these are all pieces of 2x4. So a long piece of 2x4 this way. This would be attached, that's attached, and those two are attached. This is asking you to figure out how much wood you're going to need altogether. So what I'm going to get you to focus on, actually maybe I'm going to get you to think about that for a few minutes. How would you do this? All right, so I'm going to get you to start in this triangle right here, like this, because that's a right angle. This should be half of 16, so that's going to be 8. And let's call this x. So I want you to start by using the Pythagorean theorem on that blue triangle. Again, I'm going to pause now because I think you should do this on your own, using proper form, and then we'll discuss it. Okay, so we're back now. Notice I started with my introduction. H squared equals a squared plus b squared. I drew my arrow pointing to the hypotenuse, so it's now pointing to the side that's x. So I now have x squared. This side is length 8. This side is length 8. So I have 8 squared plus 8 squared. So we get x squared is 64 plus 64. That is 128. So x squared is 128. Now x is the square root of 128. And that gives us 11.3. So we now know, I'm going to change this color to red, we now know that that is also 11.3. So now what I'm going to get you to focus on is a different triangle. I'm going to get you to focus on this one right here. We do know that that is 8. We don't know how long this is, so let's call that y. And then see if you can figure out how long this is. So I'm going to give you a few seconds to think about that. How long is that? Again, I'm going to pause the video. That allows me to do some writing, which makes the video shorter. But when I pause, you should physically be pausing the video so you can do some thinking. All right. The length of this little bit here should be half of 11.3. Now 11.3 divided by 2 is 5.65. So now I'm sending you back to the Pythagorean theorem. Here is our right triangle. Notice where the right angle is, right here. Set up the Pythagorean theorem using proper form and figure out how long y is. Again, I'm going to pause. And when I'm pausing, I would like you to be doing this work on a piece of paper using proper form as shown over here. While you're working, I'm also going to be working, and then we'll discuss the solution. So please pause now. Okay, we're back now. I started with my introduction. I meant to write it in green, but I wrote it in red, so I'm going to leave that. H squared equals a squared plus b squared. Should draw this on so that you can see. That is the hypotenuse. The hypotenuse is 8. Plugging in there, 8 squared is the legs are 5.65, and y over here is another leg. So y squared plus 5.65 all squared. 8 squared is 64. 5.65 all squared is 31.9225. And again, we're going to focus on when you're isolating for a leg, you're going to have to think about solving equations. The additive inverse of plus 31.9225 is negative 31.9225. So we now have 64 minus 31.9225 is y squared. That gives us 32.0775 is y squared. The square root of 32.0775 is y, because you undo this with the square root. And that gives me y is approximately 5. There should be a decimal there, 0.7. All right. If 10 trusses were going to be used altogether, how many linear feet to construct 10 of these for our roof line? You now know the length of all of the sides. You know that's 11.3. That's 11.3. All the way across here is 16, that's 8, and you know the length of these two. So find the amount of linear feet for one truss and then for 10. And again, I'm going to pause to let you do the work, and I'll be doing it at the same time. So you're going to pause the recording now. Okay, so we're back now. I'm noting that to construct one truss, I need two sides at 11.3, one here and one here. I need a side of length 16, which is right along there. I need a side at length 8, which is right there. And now I have two side lengths at 5.7, one here and one here. 2 times 11.3 is 22.6. 2 times 5.7 is 11.4. 22.6 plus 24 plus 11.4 is 28. So in one truss, we're going to need 58. I should put the marking on there. We're going to need 58 linear feet. If we're going to build 10 trusses, then I'm going to need 10 times 58. and that gives me 580 linear feet for 10 trusses. Okay, thus we'll conclude our little review on the Pythagorean theorem. I will also post a unit outline, and you can attempt to try to do extra homework problems from the textbook. And eventually I'll move on to lesson 2 from this unit. So if you made it to the end, good for you.